This lesson is on surface area. We'll start with rectangular prisms. We have the formula where we have base times height, because that's the formula of area of a rectangle. So base times height times 2, because there are two identical rectangles that are faces of this rectangular prism. And then the base times height of the second face times 2, since there are two matches. And then base times height of the third rectangle times 2. What we mean by the matches is once we find the area of this rectangle, we know that the one on the opposite side of it is the same. So that's why we're multiplying times 2. And then we get a different rectangle, base. We do rectangle number 2, multiply it times 2 because the top and bottom are the same. And then rectangle number 3, we know that the front and the back, these rectangles are also the same. But remember, you don't have to worry and concern yourself with which one's the first one, which one's the second, and which is the third, as long as you do 3 different rectangles. So we have the 3 dimensions, 6 inches, 5 inches, and 4 inches. So I can take the dimensions of 6 times 5 to find the area of one of the rectangles. And then I'll multiply that times 2, plus area of another rectangle, 6 times 4, and multiply that times 2. And then find the area of the third set, which is 5 times 4, and multiply that times 2. So now once you have this set up, again you can double check to make sure that you paired up the dimensions correctly. You should have 6 and 5 paired together, 6 and 4 paired together, and 5 and 4. Again, the order in which you have these paired doesn't matter as long as you have the 3 different sets. So this would equal 60, plus this is 48, plus this is 40. You add that together and get a surface area of 148 square inches. Now for triangular prisms, you can think of it in 2 different ways. One that will work for any triangular prisms, or there is one that's a little shortcut if it's an equilateral triangle. We'll talk about that in a moment. But first, the one that will work for any triangular prism. Remember, the formula for area of triangles is half of the base times the height. So this T stands for the triangle. We're going to take half of the base of the triangle times the height of the triangle. And again, we're going to multiply it times 2 because this triangle has a match on this side of the prism. Same exact size triangles. And then there are 3 rectangles that form the 3 center faces of the triangular prism. So we have to find the area. This A stands for area of rectangle 1, area of rectangle 2, plus area of rectangle 3. First of all, the triangle has a base of 8 and a height of 6.
Pardon me, teachers. I know this is a dismissal. Please report to the cafeteria rather than family lifestyle eating room. Please report to the cafeteria for the meeting at 3:30. Thank you.
And then, so again, I'll back up. This is the area of the triangle, half of the base of 8 times the height of 6. We're multiplying it times 2 because there are 2 identical triangles on either side of this prism. Then we have to now find the area of the different rectangles that make up this prism. So if we look at this rectangle here in the front, it's 9 by 10, 9 meters by 10 meters. So we'll multiply 9 times 10. Then if we take a look at this rectangle back here, it's 9 by 6, 9 meters by 6 meters. So we'll multiply that. And then across the bottom, we would have one that's 9 meters, because if this would be the same length as that. That's 9 meters, this is 9 meters. So 9 by 8. And then we do the math. This would be 48 plus 90 plus 54 plus 72 would equal 264 square meters. Now what we mean by an equilateral triangle is that in this triangle all 3 sides are the same length. You see this is marked as 6 meters, and then these dashes tell us that all 3 sides would be the same. So I'm going to do the area of the triangle the same. I'm going to do half of the base of the triangle, which is 6, times its height, which is 5. This dotted line represents the height. It's 5 meters times 2. So this was to find the area of both triangles since they are congruent on either side of the prism. Because it's an equilateral triangle, all three rectangles in this prism will be the same size. So once I find the area of one rectangle, I just have to multiply it times 3 because all of them are the same. So since this rectangle is 12 by 6, then I know if I multiply 12 times 6 times 3, I'm going to find the area of all three rectangles. And to prove they're all the same, we looked at this one was 12 by 6. If we erase that and we look at a different rectangle now. We look at this one that's going across the bottom. This one is 12 by 6 as well. And then if we look at the one that's going across the back, this would be 12, this would be 6. Or we can look at it this, if we complete it, 12 by 6 or 12 by 6. So half of 6 times 5 times 2 would give us 30. And then we have 12 times 6 times 3 would be 216. So that would give us 246 square meters. Then we have cylinders. To find the surface area of cylinders, we need to know the formula for area of a circle, but in case we've forgotten, I wrote it down here. If we find the area of the circle, we'll find the area of this base, and we multiply it times 2 because this base has a match down here, a circle of the same size. Then to find the area of the circular face that goes around the center, that if we cut it out, it would be like the label on a can. If you take the label off of a can, it's a rectangle. To find the length of the base of that rectangle, we would have to find the circumference of the circle, which as a reminder, that's pi times diameter. Multiply that times the height of the cylinder would be like the height of the rectangle. So we're finding the area of the circle, multiplying it times 2, because there are two circles of the same size. Then we'll find the circumference of the circle, because that would tell us, you can say the length of the can label, that rectangle that connects the two circular bases, times the height of the cylinder. So first of all, we'll do pi times the radius, which is marked here as 9, times the radius again, times 2, to find the area of the two circles. Then we have to multiply pi times the diameter. Well, if the radius is 9, then we know the diameter would be 18, times the height of the cylinder, which is 6. And we punch all of that in, and this would be 508 and 6800ths, and we will end up rounding to the nearest tenth. But we'll add what comes up on our calculators, and then we will round the final answer if we need to. This one comes out to the nearest tenth. For this second cylinder, we'll follow the same procedure. We're going to do pi times the radius times 2. We're going to find the area of the circle and then multiply it times 2. Well, the radius is not given to us in this circle. The diameter is. So if the diameter is 34, the radius is going to be half of that, which is 17. So pi times 17 times 17 times 2 would give us the area of the two circles. Then we have to find the circumference of the circle, which is pi times the diameter, which is 34, times the height of the cylinder. Height of the cylinder is marked here as 10 meters. Now we multiply all that. Remember that we're going to keep what's on our calculator until we get to the final answer, which we will then round to the nearest tenth. So this equals 2,882 and 5200ths, and we will round that to 2,882 and 5/10 square meters.